There's something that doesn't make sense in South Africa. We are surrounded by water, thousands of kilometers of coastline, two massive oceans, and yet we still run out of water. We've all experienced it. Water cuts, low pressure, taps running dry when you need them most. And at the same time, you can stand at the coast, look out at an endless ocean, and there's water everywhere. So the obvious question is, why can't we just take that water and use it? Because if you really think about it, it should be simple. We already treat water, we already build massive infrastructure, we already move water across long distances. So what's stopping us? And this is where it gets interesting, because the answer is not just remove the salt. There's a much bigger problem hiding underneath that idea. And once you understand it, you'll see why the ocean is not just an easy solution that people think it is. The answer seems obvious. We can't drink water from the ocean because it's salty. And it's not just a bit salty. Seawater is packed with dissolved salts, mainly sodium chloride, at levels that your body simply cannot handle. Here's what actually happens in simple terms. Your body needs fresh water to function, but when you drink seawater, you're taking in way too much salt. So to flush that salt out, your body has to use more fresh water than you just drank. Think of it like this. Imagine you accidentally pour a cup of salt into a bucket of clean water. To fix it, you have to keep adding more and more clean water to dilute it. That clean water your body uses comes from inside of you. So instead of hydrating you, seawater actually drains your body of water. That's why drinking seawater doesn't hydrate you. It dehydrates you even faster. So naturally, the solution seems simple. Just remove the salt. And here's the thing, we actually can. There's a process called desalination. Engineers take seawater, push it through extremely fine filters under very high pressure, and separate the salt from the water. At the end of that process, you get clean, drinkable water. So now you're probably thinking, okay, so what's the problem then? Because if we already have the technology, if we can already turn ocean water into drinking water, then why isn't every coastal city in South Africa doing this at a massive scale? And this is where the real problem starts, because removing the salt is actually the easy part. So if removing the salt is the easy part, what's actually stopping us? The answer is energy. Desalination sounds simple on paper. Take seawater, push it through a filter, get clean water out. But in reality, you have to force that water through extremely fine membranes at very high pressure. We're talking about pressure so high that you're basically fighting against the natural force of salt wanting to stay dissolved in water. Think about it this way. Imagine trying to push water through something as tight as a coffee filter, but instead of using gravity, you're using pressure. Now, imagine doing that for millions of liters of water every single day. That takes a massive amount of electricity, not just a little bit, a lot. Now, bring that back to South Africa. We already struggle with electricity. We already struggle with power constraints. We already struggle with a grid that is already under pressure. So now imagine adding a system that needs huge constant energy just to produce drinking water. It starts to become a very expensive problem, because it's not just about building the plant, it's about powering it every single day reliably. And that's why desalination is not as simple as it sounds. Yes, we can turn ocean water into drinking water, but doing it at the scale that South Africa needs comes at a serious cost. So now we understand the real issue. It's not that we can't turn seawater into drinking water. It's that doing it requires a lot of energy, and energy costs money, a lot of money. Desalination plants are not small projects. These are massive industrial facilities built along the coastline with complex systems, high pressure pumps, and advanced filtration equipment. Just building one could cost billions of rands. But here's the real problem. Building it is the easy part. Running it is where things get really expensive real quick. Every single day, you need electricity to keep that system running, non-stop, no breaks, because the moment you stop, the water stops. So now imagine this. You build a desalination plant to supply water to a city, but your electricity supply is unstable. Load shedding kicks in. Power cuts happen. What do you think happens to the water supply then? It becomes unreliable. Now, you've spent billions of rands and you still can't guarantee water. And it gets worse. Most of South Africa's biggest cities like Johannesburg, like Pretoria, are not even near the ocean. They are hundreds of kilometers inland. So even if you produce clean water at the coast, you still have to move it over long distances, across provinces, up in elevation. And moving water like that also takes energy. It also costs money. So now you're not just paying to clean the water, you're paying to transport it as well. And suddenly, this simple solution becomes one of the most expensive ways to supply water, which is why desalination is used very carefully. Not everywhere and not at the scale most people imagine. Because the real question is not, can we do it? The real question is, can we afford to do it at scale? So does that mean desalination is useless? Not at all. It just means it has to be used in the right place. Desalination works best in coastal cities, places where the ocean is right there and you don't have to move the water very far. And South Africa actually already does this. Cities like Cape Town have desalination plants that were brought in during the drought, not to replace the entire water system, but to support it, to give the city extra supply when dams run too low. Because that's the key idea here. Desalination is not the main solution, it's a backup. Think of it like a generator during load shedding. You don't power the entire country with generators. That would be too expensive, but when the power goes out, that generator becomes very important. Desalination works the same way. When rainfall is too low, when dams are under too much pressure, or when the demand is too high, desalination can step in and help. But for inland cities like Johannesburg, it becomes much harder to justify because now you're dealing with 3 problems at once. You have to clean the water, you have to move it along long distances, and you have to lift it to a higher elevation. Each one costs money. Each one needs energy, lots of it. So instead of relying on the ocean, South Africa does something else. We move water from where it naturally exists to where it's needed. And this is where things start to come full circle because the real solution South Africa depends on is not the ocean at all. So if we're not relying on the ocean, where does our water actually come from? The answer is the sky in the form of rain. But not just any rain, rain in the right places. Because South Africa is a semi-arid country, meaning most of our land does not receive consistent high rainfall. And the areas where the most people live are not always the areas where the most rain falls. So instead of trying to create new water from the ocean, we focus on something much more efficient. We capture the water where it naturally forms and then we move it. Think about it like this. Imagine one side of the country has a full water tank and the other side is running dry. Instead of trying to create new water from scratch, it makes more sense to move the water from where it's available to where it's needed. That's exactly what South Africa does. We build dams to store our water. We build pipelines and tunnels to move that water, and we connect entire regions through large-scale transfer systems. And some of these systems are massive. They are huge. Water is moved across provinces. Water is moved across long distances, sometimes even across borders, all to make sure that cities, industries, and communities have a reliable supply of water. Because in a country like ours, water is not always where the people are. So the real engineering challenge is not just treating the water, it's moving this water. Even with all this infrastructure, even with dams, pipelines, and transfer systems, we are still losing a huge amount of water. And not because we don't have enough, but because we're wasting what we already have. In some South African cities, a massive portion of treated water never even reaches your tap. It leaks through old pipes, broken infrastructure, poor maintenance, water that has already been collected, already been treated, already been pumped, just disappears into the ground. We're talking about spending billions to build desalination plants, billions to move water across the country, while at the same time losing water every single day through leaks. It's like trying to fill a bucket with holes at the bottom. You can pour in as much water as you want, but it will never stay full. And this is why the solution to South Africa's water problem is not just about building more. It will never be about just building more. It's about fixing what we already have, maintaining infrastructure, reducing leaks, managing demand, because every drop we save is a drop we don't have to produce or move. Yes, South Africa is surrounded by water. Yes, we have the technology to turn seawater into drinking water. But no, it's not the simple solution people think it is. Because the real challenge is not just about having water. It's about how much it costs to produce it, to move it, and to keep it flowing reliably. Desalination works, but it comes with high energy demands, high costs, and major infrastructure requirements. It makes sense in specific situations, especially for coastal cities, but it cannot carry the entire country. Hi everyone, the South African engineer here. If this explanation was useful, please like the video, subscribe, and turn on your notifications. Every subscription is a brick used to build the Engineering Explained house. Let's build this house together. Thank you for watching.